Okay. Hello and welcome to my presentation. The presentation is about an overview of electric power and energy systems. I'm Dr. Sajeeb Saha. And before going to the main presentation, let me pose a question. The question is about can you name one thing which, if we take out of our daily life, our life would be stopped? The answer is very obvious. It is electricity. So, if you take out electricity from our life, I think we cannot guess what our life would be. Here, there is a picture of Northeast blackout happened in 2003, and it is a snapshot of New York City at that particular time, and it affected about 55 million people at that time. So, the point of putting this picture to emphasizing how electricity is important to us, and power system is the system which transmits this electricity to our daily life. So this is the outline of the talk. First I will be showing a simple electric circuits, and then I'll be talking about the war of currents, and then we will talk about the basic structure of power system, then goals and complications or challenges in power system operations, environmental issues, then we'll introduce the renewable energy sources, then power generation in Australia, then we'll conclude the presentation. First, look at the simple electric circuits. We have two circuits, one AC circuit, the other one is DC circuit. In AC circuit, the voltage or the generation varies with time, as you can see from the blue line here, and the current flowing will be moving back and forth, as you can see from the first picture. In the DC, the voltage generation is time invariant, it doesn't vary with time. And as you can see from there, the current direction is in one directional. And if you look at here, the simple power system is actually like a simple electric power circuit, where we have a generation, transmission, and a load end which consumes the generated power. But before moving to the simple or the basic structure of power system, we need to know that today's world is dominated by AC power system. How the AC power system actually won the race over the DC, we will be looking into the next few slides. There was a war of current going on in the late 19th century, and Thomas Alva Edison was actually advocating for the DC currents. But the main problem with the DC circuit was you cannot transmit power to a very long distance. And then the George Westinghouse and Nikola Tesla came into the picture, and they were advocating about the AC power system. And the main game changer was William Stanley, and he actually developed the first practical AC transformer, where we have the power can be transformed from the high voltage level to the low voltage level, depending on the turns ratio we put in the primary side of the transformer to the secondary side of the transformer. As you can see from the relationship shown here, the voltage and the currents in the primary and secondary side is related to number of turns we provide in the primary and the secondary. So changing the various number of turns in the primary and secondary, we can actually have different voltage levels. That's how the AC power system won the race about the DC power system. And they can transmit power for a very long distance, which cannot be the case for the DC power systems. So that's how we have all the power system in today's world is 50 Hz or 60 Hz, depending on the nation, of three-phase power systems, AC power systems. So let's look into the structure, how the transformer changed. So we generate the power, we step up the voltage, and eventually the current goes down, and we can transmit the power with a loss, very small loss, which is depending on the amount of current we transmit through the high voltage transmission lines. And in the consumer end, depending on the voltage levels, we can actually step down by the transformer and provide it to the end consumers. So look at the basic structure of the modern power systems. As you can see from here, it is very much like the electric power circuits, where we have the generation, transmission, and distribution. We generate the power and we step it up to higher voltage level, as you can see from here, and then we actually step it down, and at different voltage level consumers, we have different step down transformers, and we provide it to different the consumers. As you can see here, the commercial, industrial, and the household loads. So the generation, as you can see from here, we have power plants where we actually generate the power or the transform other sources of electric energy, say for example heat, thermal, steam, wind, solar, to electrical energy sources. And by the transmission system, before going to the transmission system, as we have shown, we have a transformer, we step it up, the current goes down, and then we can transform it more efficiently through the high voltage transmission network where we have less losses. And then in the distribution end, we have different voltage level end consumers where we step it down by the step down transformers and we provide it to the consumers. So if you look at the basic structure is more or less like the normal electric circuits. But we need to provide the main goals of power system. We need to provide a voltage level of 240, say for example, at the household levels at all time. So we need to make the voltage level constant and the frequency should be constant around 50 or 60 hertz. 50 hertz in Australia and other parts of the world and 60 hertz in the mostly in the US countries. And we need to be concerned about the cost as well. The other major thing we need to think about the electric power system is real-time energy systems. So that means we need to generate and match the demand at the same amount of time. And unlike the electric circuits, the load demand or the load demand is varying over the day, as you can see from here. So we need to have efficient, reliable and cost-effective power transmission over the whole generation, transmission and distribution. So we have some other issues regarding the environmental issues, because most of the power generation these days uses fossil fuel type power plants where we burn the fossil fuels, which is the coal, the oils and all these things, which produces huge number of carbon dioxide, which has a huge impact on the environment, which causes the greenhouse gas effect and which is the main reason for the global warming. So people are moving and trying to get rid of this global warming and very much concerned about this. And here comes in the picture the renewable energy sources, which is more environmental friendly. So if you look at the renewable energy sources, as you can see, the renewable energy sources are those sources which are the naturally feeling. So it is refilled by the nature. So we can have sunlight, wind, rain, tides, waves, geothermal and all these things. And we have the mostly commonly used is the PV solar, the wind and the biomass. And if you look at the public opinion, the public is also are very much concerned of the environmental issues for the better world or the safer world and very environmental friendly world. As you can see, the people perception about the solar, they want the solar to dominate because it has less impact on the environment. As you can, wind, hydraulic and the coal is very less, and the nuclear, obvious reason, is very much not people are liking that much these days. But the renewable energy sources are not very much like have that much of generation. That's why, as you can see from this chart, in Australia we have mostly coal, which is generating about 73% of the total energy demand, and the very little is coming from the renewable energy sources. But the good sign is over the years, as you can see from June 2006 to June 2014, the generation of renewable energy sources has increased slowly but steadily. But the coals are going down, as you can see from the black and the red lines. So now in the conclusion, as we can see, we have provided a simple picture of power system, but in practical sense, power system is a very large interconnected system. And we have associated controls which controls the voltage and the frequency levels, and we have the protection devices which takes out the faulty parts from the power systems. So now, in order to have the better understanding, I would recommend these two books for the references. And if you have any questions regarding this, you can write to me in my email address, which is provided in the first page. And thank you very much for paying kind attention.